If you'd like to turn to page 5 in your book, we're going to have a look at areas of plane figures now. The first group that we're going to look at are just triangles, because there are 3 different ways, depending on the information you're given, to work out the area of the triangles. So you can see there that the area is measured by the amount of space enclosed by it. So if you have your plane shape, in this case a triangle, all this area inside here, or this space inside here, is called the area. So I'm sure in high school you've looked at this basic formula. Area equals half times the base times the height within your triangle. And just a reminder that the height is always measured at right angles to the base. So whatever way the triangle is, if you want to work out the height, just remember, draw a line down and it must be at right angles to the base. The second formula that we're going to look at, you may or not have seen this one before, is if you don't have the height, like in the first example, you might have some sides and an angle. So this is when you would use this formula. Area equals half times side A times side B times by sine of C. So C is the angle between 2 known sides A and B. So for example, this is side A, we'd call that angle A. This is side B, and we'd call this angle B. This is side C, and we call that, as it's written there, angle C. So that's where the formula comes from, but it only works if you have 2 sides and enclosed in them is the angle that you've been given. So if you were given these 2 angles and these 2 sides, you'd have to work out this unknown one. We'll get to those sort of problems a little bit later on. And the third formula is called Heron's formula. Looks a bit more complicated than it is. This is when you're given no angles at all and you're just given 3 sides, A, B and C. So the formula looks like this. Area equals the square root of the semi-perimeter formula, in brackets S minus A, brackets S minus B, brackets S minus C, brackets, where S is what we call half the perimeter, or the semi-perimeter, and we get that just by adding up all the sides. A plus B plus C equals and divided by 2. So we'll get to an example of that as well. So it looks more complicated than it actually is. So here are our 3 formulas, just a reminder. So you use the first formula when you know the base and the height. You use the second formula when you know 2 sides and the angle in between it. And you use the third formula when you just know the 3 sides only. Let's have a go at some problems there at the middle of the page. So volume 1.4 with your teacher section. So what have we got here? We have our first example where we've got our base and our height. So we're going to use that first formula. So make sure you write down all the formulas that you're using. And then it's just a matter of writing in. This is B for base, and here's 3.2 for height. So if we just write those in, half times 6.5 times 3.2, and everything you can see there's in centimetres. So our answer is going to be in centimetres. But because we've got an area, our units, one side times by another, is squared. So don't forget that little squared symbol. That's really easy to forget, but it's really important to remember it. So A for area, area equals 10.4 centimetres squared. Let's have a look at our second example there. We have our base of 4.2 metres, and this time we're giving our height, and so it's really important that it's measured at right angles to the base. That's what that means in terms of that little note there in yellow. So again, we're going to use the same formula. Area equals half base times height. So half of 4.2 times by our height of 4 will give us an area of 8.4, and this times meters squared. In our third example, I've noticed we've got two sides and an angle in between, and so this time we need to use the formula that is half times side A times side B with angle C in between it. So two sides with an angle in between means we use this formula. A equals half AB times sine C. So it doesn't actually matter which one you call A and which one you call B, because you'll come up with the same answer because you're multiplying them together. And so half times 7.2 times 6.4 times sine 28 gives us an area of 10.82, and we're in centimetres again, centimetres squared. In this next example, we're still going to use the same formula that we had in the previous example because we've got two sides, but the problem is we don't have this angle here. So we need to work that out first. So if you recall from high school, to work out the angles in a triangle, remember all these angles add up to 180 degrees. So if we know this one and this and take it away from 180, we can work out this angle. So angle C, which is what we're going to use in this formula, is equal to 180 minus these two angles. And what that adds up to is 120 degrees. So 180 minus 120 gives us that angle of 60 here. And so now we're in this situation, we've got two sides and our angle in between. So we can now then insert that into the half AB sine C formula for area. So it takes a little bit to write everything out, but it also helps you by writing the formula and substituting into the right section. It also helps you to get it right. And so that equals 17.07 metres squared. So just use your normal calculator, your scientific calculator, to work this out. So you press sign, there's a sign button on your scientific calculator. Alternatively, you can use the graphics calculator. In our last two examples, we're going to look at Heron's formula. So you can see in these examples, we just have three sides, but no angles at all. So we must use Heron's formula to work these ones out. So the first thing that we need to do with Heron's formula is we must work out that half, or that semi-perimeter. So that formula is adding up all sides, and then once we've pressed equals, then dividing that by 2. So if we have a look at that, we've got 5 plus 6 plus 7, and then divide that by 2. So that's 18 divided by 2, and our half perimeter is equal to 9 centimetres. So now that we've got that, we can put that into the formula. So the formula is area equals the square root, and I'll just write it out. So always remember your square root. So every time we see an S, we're going to put a 9 in. So 9 minus 5, 9 minus 6, 9 minus 7. So 9 minus 5 is 4, 9 minus 6 is 3, 9 minus 7 is 2. So it's just times by 9 times 4 times 3 times 2. And so that works out to be the square root of 216. You're putting that in your calculator. And therefore area equals 14.7 metres squared. So there's a fair bit of working out, and there's a few places where you can make a mistake. If you make a mistake here, that follows on here. So just make sure that you double check before you move on to that second part of the formula. Okay, let's have a look at this second one here. I'll write it a little bit smaller so that we can fit it all in. So recognising we've got 3 sides only, so we need to do our semi-perimeter. So adding them all up, 10.1 plus 14.2 plus 9.6, and then dividing it all by 2 will give us the answer of 33.9 divided by 2, and that equals 16.95 metres. So then using that in our new Heron's formula, so it takes a bit of time, but that's part of communication. So 16.95 minus A, and I haven't got much space to fit this in. Comes out as, you were going to put that all in your calculator, make sure you've got brackets around everything, 2,346.82, and then we've got to square root that to get the area for this triangle at 48.44 metres squared. And there you have Heron's formula. It takes a bit of time, double check your work, and you should come up with the right answer.